Hey there. This is my second video in the series of learning functional programming thinking with Elixir and by doing some algorithms. So in this video, I would like to explain why why we should care about learning functional programming. So since we know imperative language, we know imperative mental process of solving a problem. So that's what we have grown up with. And whenever I see any problem that I have to solve, I think in terms of changing the state and everything. But to kind of make point, explain it well, I would take a simple example. But before that, uh, functional programming as function is in the name. So if we have any function, right? So the basic building block of functional programming is function, right? Makes sense. So if we have any function, let's say add, and it takes a and b, and it returns a plus b. So this is Ruby. There's no return in return keyword here. So this is the basic fundamental idea of functional programming. That is a function. Whenever we call it inputs, it returns the same output. It's called pure function. So I will explain these, functional programming concepts as I go along. So we would solve a simple basic problem, which is sum of squares. Sum of squares. And for that, I will take an array, right? Because we need an array. So we have this array. I will copy it. So what's the first thing that we need to do? We need to, for each item, we need to square it. So 1 times 1, 2 times 2, 3 times 2, 3 times 3. So in imperative, what we would do is we would run a loop from 0 to 9. In this case, that would be nums.length. And then what we would do is we would take this each index one by one, read the value, write it back before we square it. So we say at this value, copy over index like this times nums.index, right? So this would square it. Why is it complaining? We need in here. Anyways, so now if we were to kind of print it, and if I do that, so I would run a Ruby REPL, and if I run this code, so if I say nums, we have the squares for each number, right? Now we have to sum it. So I would create a new global variable, which is sum, and I will initialize it with 0, right? And now what I would do is I would loop again, and then I would say sum plus equals index. And if I do it, run it here, so I should have sum 385. So as you can see, like, imperative way is mostly trying to solve a problem in how manner. So we specify to the computer that this is exactly how you need to do, what are the things you need to do, how you do it, and to solve this problem. But functional programming is more of like data transformation. We take this data, transform it step by step, right? So I'll explain the concepts here. So we explained pure function. That is, a function returns same value every time with same inputs, right? We will take this, where is it? What we would do is we would take this, copy it, right? So we have this nums area here, and what we would do is we would say, okay, we would map it, right? So we would take this array, and we say nums, we run a function on each element, right? So first, this map function would give us 1, then 2, then 3, and then it asks us what do you need to do with this element. So we would return x. So it gives us element. Better would be item here for clarity, right? So we would say, or maybe num, makes sense. So what we would return is num times num. So important thing here to notice is that it gives us new nums array, right? It gives us new nums array. And here comes another jargon, which is immutability. Mutability, which is we don't mutate data here. So here in Ruby, we mutated the SAM array. We updated, read the value, updated, done some operations and wrote it back here. But that is not how things work here in Elixir or maybe in any functional programming language. There's no mutation. Data is immutable. We could define it something like this, right? We could define this variable again, but it binds the value here, right? So it shadows the previous one, but then binds the new value here with this. But it doesn't mutate the data, right? That isn't to say like we can't say nums of 0 equal to, this can't be done, right? Now we have the new nums array, and new nums array is the, what you can say, the squared, right? And then we would take this nums array, new squared array, we would sum it, we would run another transformation, right? We would say reduce, and it takes now new nums and new nums, and then it takes the accumulator, which is the sum, you can say sum, and then it also takes a function. It gives us accumulator and the num. What we need to return is accumulator plus num. So here comes another jargon, which is higher order functions, which means we can, return and take functions, send functions and send functions as arguments, and we can also return new functions from functions themselves. These are called higher order functions, and there's also concept of first order functions, or functions as first class citizens. That is to say that we can move and move functions as we would normally do with objects. We can store a function, right? Like let this is not the correct syntax, but let's imagine for the sake of simplicity. So there's some JavaScript notation here, right? So we gonna store this function reference in some fun, right? So this is actually first order function, that we are treating functions as same as we are treating objects, right? So we are actually sending these functions here, and this would give us sum, right? This would give us sum. As you can see, this is much more readable, not at the moment, but we will make it readable. But before that, let's do one thing. Let's create, for these functions, we will separate them out. We would say square x, and what this will do is this will return x times x. So this will square any number. That's exactly what is happening here. And for this thing, it is simple addition here, right? This function is simple addition, nothing more than that. So add a comma b, and then what we can do is do no, we didn't need and here. So a plus b, right? Simple as that. Now we can replace this weird looking code with square. So but we need to follow the syntax of the Elixir, which is when we pass a function, we have to say this ampersand here and then square, and then we have to define a parity, specify parity. So what is the number of argument that this function takes, which is 1. And then sum here, we would say add, and this parity is 2. But this won't work. This code is not going to run. To make it run, we need to define it inside a module. So we would say def module a test do, and then we define the function run do, and we move it inside here, and we need to move these functions outside in the module, right, like that. And then we just do some indentation. And now this is a little bit more readable. We have nums. We are saying, okay, square them, each number, map. And then we are taking that new nums and, uh, you know, reducing that to sum. But we can make it more readable with Elixir's pipe operator. So what we would do is we would comment it out. This really gets interesting here. Sorry, so Control Z, move it here, and we don't need to define anything. So what I would do is we have this array. This is a pipe operator in Elixir. What this will do is this will take this, this array, give it to this new function. So where's the function? There's enum dot map, and we say we didn't have to specify nums here because nums will be automatically passed to this function as a first argument, and the second argument would be square. We define a parity here, and then we take this nums reduce as add 2, and this would return us sum, right? But what we would do is we will give it to the standard output by saying puts. Now this same code is the code here. Look how beautiful it is. So this is the data. We're taking it, giving it to the map. We're saying transform it. It is returning new array of squared numbers. Then we are taking the squared numbers and giving it to reduce. This will add each and every item in the list, give us back the sum, and we're taking the sum, giving it to the standard output. Now here comes the next jargon, which is composability. That is to say, we use functions, other functions in functions, and we take these code fragments as functions and kind of mix and match them, compose them, and to make our program readable. So as you can see, this is much more readable. This is maintainable, right? We kind of break our program, our logic into different functions that are pure functions that are easy to test, easy to maintain, right? Easy to understand, predictable, right? So these are the advantages of function programming, right? Now let's give it a run. I will create a terminal. I will exit, and I will say ix mix. So this will load this mix project. This is a mix project I'm maintaining, and what I will do is test.run. Oh no. So as you can see, we have 385, which is correct. So look at this code and this code, right? It's beautiful, right? So these were some jargon words, and so my motivation to learn functional programming is mostly to kind of learn this another paradigm, learn Elixir, and kind of grab good ideas from functional language, functional paradigm, and introduce kind of add them to my existing you know uh, imperative or Ruby. And really I would like to love to code in Elixir full time. Yeah, that's pretty much it. Next we will see bubble sort.